Hi, I'm Pete Broderick, and I'm going to talk to you about Ruby closures. Have you ever wondered how in the Rails framework, things like each on an array or the view helpers like form4 work? If so, you're in luck, because today we are going to show you exactly how those work. And before I can really get into that, I need to show you a few things about Ruby itself. So today we are using Ruby version 2.1, and I'm going to use something called a REPL called pry, which will allow me to evaluate Ruby commands. And I'm also going to be using Sublime Text so that I can write Ruby code and paste it into this REPL more easily. Okay. So a closure is a block of code that can be stored and used later. So you can store this code as a variable and then invoke it later. And it also has another interesting property in that it inherits the environment in which it was created. So let me give you an example. We're going to define a method called env, which is going to stand for environment, and create some variables, some local variables, a, b, and c. So with this environment set up, I'm going to create the first of 3 different types of Ruby closures. This one is called a lambda. Now lambdas are either created by using the lambda or shorthand stabby lambda and passing a block of code inside curly braces or a do end block. So for this example, I'm just going to use the curly braces and pass a plus b plus c. Now if I copy this over into my REPL, then I call env, oops, I forgot to actually call the lambda. Let's try that again. And we get 7, which is 1 plus 2 plus 3. So what we did here is we created an anonymous function, which is called a lambda. And it is a block of code that we have stored as a variable called lam. And it inherited a, b, and c, the local variables inside, which are the environment in which it was created. So lambdas have some other interesting properties. They basically behave like Ruby methods, stored Ruby methods. So they have the same method argument semantics, which means that they will behave exactly like a method if you don't pass arguments that it expects. So for instance, if we say that this accepts an argument d, and we add d here, we can run this again, and if we invoke env, we'll get an error. Wrong number of arguments, 0 for 1. So in order to make this actually work, we would need to pass in something for d. So I'll pass in a value 10. We should get 17. So just for completeness, I'll rewrite this in the other way it can be written. which would be lambda d and also you can, for multi-line, the typical convention is to use do end. So another thing that's interesting about lambdas, and different from the next type of closure I'm going to talk about, is that lambda's return behaves just like you would expect a method return to behave. So if I return a plus b plus c plus d, it will behave no different. We returned from our lambda back into our env method after it was called. Okay, so now we're going to talk about a different type of closure called a proc. Procs are also blocks of code that can be passed around and stored as variables. And they are defined like this. I'll use our do end syntax, and we'll call this a proc. And for right now, I'm going to get rid of this return statement, and I'll explain why in a minute. Okay. Now if we invoke env, we get the same result. Now a difference here between the lambda and this proc is that if I remove this 10 and pass no arguments, we will not get that argument, 0 arguments for 1 error. Instead, we get an error saying that we can't add nil to a plus c. So we can't add nil to a fixed num. So procs have what you call assignment semantics, argument assignment semantics. So this means that arguments that are missing will automatically be assigned to nil. This allows more flexibility. You can check if you can easily check if arguments were passed in and behave differently. So we could say unless d, or we'll say if d is nil, then only add a plus c, else. I got my tabs all messed up here. Otherwise, a plus c plus d. Right, so we only added our a plus c, 1 plus 3, and got 4. Okay, another difference is the way that procs handle return. So if I change this so that we return the value, and then let's say I want to invoke our proc, but then I want to do something else, like puts hello. So with a lambda, we would return from that block of code, and then we would output hello. But in this case, the proc return returns from the parent function, so we never output hello. So it's not very typical that you see return statements inside procs, but you will see them inside lambdas. So now I'm going to talk about blocks and what makes blocks very interesting in the Ruby language. Blocks you will see all over Ruby land and inside the Rails framework. And the interesting thing about them in Ruby is that every method can receive a block. So if I create a method A, and paste it over into our REPL, I can call A with some block of code. Now it won't do anything with it, and it will return nil because nothing is happening inside A, but it accepts it just fine. Now if I change this method to instead yield the block that was passed to it, this 1 plus 2 will get evaluated. So what yield does is just evaluate the block that was passed to it and then move on. So we can do things like puts hello, yield, and then puts world. Now you don't see the 3 here because my REPL will print out the last thing that was evaluated, but in this case, since we didn't puts, it didn't get output. So let's add our puts line. Now you can see hello for world. So since blocks can optionally be passed to a method, we can also easily check if one was passed. So we can change this to puts yield if block given. So now if we just invoke A, we get hello world. But if we invoke it with 1 plus 3, we get our hello for world. So blocks allow us to do very interesting things. They allow us to separate things like an each or a map. The iteration we can separate from the actual code evaluation. So I'm going to show you an example of this by recreating each. I'm going to open up our array class, and we'll create a Pete each. So we'll set up an index for iterating. Our index will be initialized to 0, and then while our index is less than the array's size, we'll loop, and we will yield the object at the index that we're iterating over. We need to increment our index so that the loop ends. So this is a very primitive implementation of each that will only work on an array. So if we do this, we can create an A, 1, 2, 3, and call p each, and pass it a block of code to say, for each element, we want to increment it by 1. Now, this didn't work because I didn't output it, so let's add our puts here. And you can see that we now have, instead of 1, 2, 3, we have 2, 3, 4. We incremented each element by 1 and output it. So another thing that blocks give us is the ability, another thing that methods give us is the ability to transform the block of code passed into a proc. So you may have heard that everything in Ruby is an object, and that's not quite true. Almost everything in Ruby is an object. In the case of blocks, blocks are not objects, but procs are objects that represent blocks. So we can convert our block to a proc as long as the last argument in the method signature is the variable that contains that block. So now, instead of yield, we can say block.call. Now these parentheses are optional. So run this again. With our puts, 2, 3, 4. Okay, so we've gone over how you might use this to separate some iteration from the code you want to evaluate while iterating. Now let's show how something like form4 or a template helper might work. So if you work with view helpers, you'll see things like this, where you can, well, let me set up some environment here. So I'll create a method called HTML, and all it will do is yield the block that's given to it. And I'll create a method called body, and it will yield the block that's given to it. And an H1, it will yield the block that's given to it. And actually this won't quite work. I need to actually create some tags here. Do the same thing for body. And the same thing for our H1 tag. Oops. So now if I define these methods, I can now use them as an HTML builder. So we can do this by calling HTML, passing it a block, and then calling body, passing it a block, and then calling H1, passing it a block, and then we'll just say that our header is hello world. And we end, and we get this output, an HTML builder. So you'll see this technique used all throughout the Rails code, the form4 helper, any any sort of wrapping function that you pass code into will use this. You'll also see this in the JSON builder, XML builder. So it's in RSpec all over the place. So it's really useful. It helps make code more succinct, and I hope that you learn something from this and can apply it into your own Ruby code.